Sorting algorithms are an essential component of computer science, as they allow for the structured organization of datasets to facilitate their processing and analysis. Conceptually, these algorithms focus on reorganizing a collection of elements according to a specific criterion, such as ascending or descending order, which is key to optimizing subsequent operations like searches or comparisons. Furthermore, there are various sorting methods, each with its own particular characteristics in terms of efficiency and complexity, meaning that their performance can vary depending on the size of the data and how it is initially distributed. Thus, the study of these algorithms focuses not only on their operation, but also on evaluating their performance under different scenarios. Consequently, the practical application of sorting algorithms involves selecting the most appropriate method based on the context and available resources, considering factors such as execution time and the number of operations required. For example, some algorithms are more efficient with small or partially sorted datasets, while others are designed to handle large volumes of information more reliably. Therefore, understanding and correctly applying sorting algorithms is fundamental to developing more efficient solutions, optimizing data handling, and ensuring better performance in computer applications.